So if we look at like Kansas, if there was a native grassland that was there, and I don't know if
Mhm.
that still exists,
Yeah.
but there's some microbial community underground functioning with the roots. If we compared that to somebody took out that grassland a long time ago, they started farming and they walked away and they're not farming anymore and a bunch of like weeds came in and it's covered like there's plants growing but it's not the native grassland that was there. It's weedy species, so it looks like, hey, this is abundant, there's plants all over it, it's thriving. But if you looked at that native grassland versus the recovering plot covered in weeds, and we looked below surface at the microbial community, what differences would there be?
Yeah, so these two environments are where I spend a lot of time comparing fungal communities across what I call old growth grasslands. So in Kansas, we actually have a ton of them. So grasslands basically have been around since the last glaciation throughout much of the Midwest. And basically from Kansas all the way to Indiana, from Canada pretty much to Mexico would have been this grassland ecosystem called the tallgrass prairie. And Kansas has some of the biggest patches of remaining tallgrass prairie of any state in the US. And I call these prairies old growth prairies or remnant prairies, meaning that they have not been disturbed. They haven't went through tillage and they haven't been overgrazed. They're just really nice prairies. They are naturally grazed by bison in the past and now with cattle at low density if it's a nice healthy prairie. And so the microbial communities in these spaces are amazing. And that's because the plant hosts for those fungi are amazing. So some of these prairie species can live more than a century. So they're sitting in the soil for decades and decades and decades and interacting with the fungal community in that same soil for decades and decades and decades. And so they have trained the fungi to be good partners for them because they're going to be there. And so these communities are often packed with super beneficial old growth fungi as well as old growth prairie plants. And that's in contrast to some of these more disturbed sites in the restorations areas that I've worked with in our post-agricultural landscapes. Basically anything you do that has disturbed the soil will disturb those mycorrhizal communities. Then the plants that reestablish tend to be the junkier, weedier plants. And they're also not very good at repairing the microbial communities. And so a shift in plant community, a shift in fungi based on the trait of land management can result in a shift in the above ground plant community. We've seen this time and time again.
Yeah, I know you've done some studies on that too. So if you had this weedy area and you wanted to get some tall grass prairie into it, is one of the paths to succession there inoculating it with AMF to get to enable those species to thrive over the weedy species that are there?
Yeah, so there's a couple paths in restoration. Managing the land in some way to reduce the nutrient accumulation from those weedy plants or from the ag history is important. So in Kansas, we often burn the landscape. I know that's not possible in all prairies everywhere. And so in those situations, they would hay it, mow it, and take that vegetation off. So it's the soil is becoming more and more nutrient limited, and that would support a community of prairie plants because they can function and they do function very well in that environment. So that's one method, and it works. But so the bulk of my research is looking at what we call microbial transplants. And so what we do is we would go to those old growth prairies, let's say in that pocket of Kansas that has an amazing prairie, collect those microbes and take that whole soil into a new prairie environment to help the plants that require those microbes establish in that new environment. And so we do this with whole soil transplants, or in many cases, I just culture the mycorrhizae from that soil and move that into the new restoration.
What's the rate of application of something like that? This is obviously large acreage. Is it as something
Sure.
as simple as spreading dust over a large area? So a really small volume of stuff goes an amazingly long way.
Yeah, so I've done a couple studies looking at inoculation density and also application method. So it depends how you distribute the inocula, how much you need. So these microorganisms are subterranean, right? So they spend their entire life cycle below ground. So finding some way to distribute that inocula below the soil surface is key. So if you were to just dust this along the surface of your plants or something, it would probably die very quickly because it hates the sun. It's not an organism that lives in the sun, it lives in the soil. So if you can find a way to inoculate your mycorrhizae below ground, that is key. And in terms of how much is required, that is a question we are still answering. So I've done a couple of these inoculation density trials, and it seems to be right around 32 kilograms per hectare is where we start to see some results, which is, I mean, that's many pounds per acre.
So in thinking of this and kind of putting it all together, if you want to ruin a prairie, start
Don't.
fertilizing it.
Yeah.
Because then those plants don't need the fungal relationship as much, because hey, it's like
Mm-hmm.
you're just giving me this stuff, I don't have to work as hard for it. Why form a trade when you're just giving it to me? The fungi die off, and then when that fertilization goes away, those plants that are there can no longer survive without that relationship.
Yeah, exactly. And they're very dispersal limited, being subterranean organisms. They can move on worms and voles and a little bit in the wind, but they're not something like a dandelion seed that's going to float around and colonize the next door neighbor's prairie, for example. And so, yeah, once they're really disturbed, it's a major problem.